Hello everyone. So please raise your hand who knows that cars can also run on hydrogen. Oh my god, a lot of people. That's bad for me. Okay, let's start. Yes, so there are a lot of slides and we'll talk about what this new technology for cars is, for vehicles, and how we're developing it at Bosch and how we're also testing it. So, the first point of our presentation is the great wonder of the 1950s. We can produce electricity from hydrogen and oxygen using a small electrical device called a fuel cell. So, who of you knows this? Okay, few of you. We can also produce energy by burning everything. That's much more spectacular, but this is a very clean way of producing electricity. And we just get water out of everything and we don't produce CO2, so very green. Okay, and they are very similar to batteries. Now, what we can do, we can group a lot of cells like we do it with batteries, and we can generate a useful amount of energy for vehicles. We did exactly the same thing with lithium-ion batteries, so nothing new up until now. But now we're getting to the really nice part. We can group all the systems together and get an engine, like for a vehicle. And it's modular, and you can put it in a car and just sell it like this. And here you see one of the final results. That's an Iveco truck. You can look that up on the internet. Here you have the Bosch module, just put inside, and you get electricity. Just a module that generates energy. So, it's a wonder, right? Okay. Here you see an overview of the system. At the heart, with the blue box, that's the stack. There's a lot of cells that get fed hydrogen, oxygen, and produce electricity. You can look at that up on the internet if you're interested. It's a public image. But let's discuss elements of the balance of plant of the stack. Balance of plant means what you need to ensure that it produces electricity. It comes from power plants, so that's where you get the plant part. Let's start with the hydrogen supply in green. We have those hydrogen tanks that contain the gas. It's not liquid. It's gas with very high pressure. And they have the big advantage, they can be refilled in 2 or 3 minutes compared to a battery that you recharge for a few more minutes, actually more close to an hour. Next, we have the air supply system. As said, you need oxygen that you get from air. It's very useful to live on Earth because you have oxygen in the air. Hooray for Earth. And then you need a cooling system like for an engine. This heats up really bad, like in a combustion engine. So we also need a traditional cooling system. In total, very similar to a diesel car. You have air, you have cooling, but what's new is the hydrogen. Okay. Now, we have the physical system. Next, we need to talk about software. It's today's software magazine after all. And what's really different from maybe your field, it's that we have embedded software here. Final goal of the software is to control the physical system that has a lot of electric actuators. Who of you is familiar with the term actuator? Okay, not enough. Electric motors. Who of you is familiar with electric? Okay, thank you. Okay, so we have a lot of small electric motors inside the whole system that we can control with our computer. There we have a software architecture diagram. At the top we have the main request to produce electricity. From that we determine the amount of oxygen and hydrogen. Here in this case we have the case for oxygen. From there we determine the amount of air we need to produce enough electricity. From this we can command individual components. Here we have the compressor. It's okay if you know what a compressor is. It's just a fan that blows air, basically. And we have valves that control the airflow to the stack. And this in total, we make a subdivision in embedded world that we have component drivers and we have application software. But it's just another way of saying we have more abstract software and software which deals with the hardware parts. So, okay, this would be the software architecture and how it controls the physical system. Everyone okay with this? Yeah, okay. It's like in the classroom. If one is okay, then everyone is okay. So, okay. This is our dreaded V cycle in the automotive world. This is how we develop software. It's a top-down, bottom-up approach where it's similar to normal software where you do the architecture first and design the modules and then you start implementing and testing. It's a little bit closer to the waterfall, a little bit, where we design the whole system at a big level compared to normal agile that you do in software. But there's always the possibility for reiteration. What does reiteration mean? You spend money. Spend money on developers redoing stuff because it wasn't okay the first time. It's great stuff. Always happens. Good type of reiteration. You just need to redesign a module. Something didn't go well at the lowest level. And yeah, that goes fast. Bad case of reiteration. You misinterpret the client requirement and you have to redo the whole thing from scratch. I see some people are laughing. I hope you don't have this experience. Okay, so best case you don't do this, but yeah, we live in the real world. Okay, how do we test our software? We develop it, we also need to test it, or yeah, let the driver test it and crash and burn and something. But okay, so we test it first. The best way of testing is everything on the PC where you develop it. But there's a huge, huge problem. We're trying to control a physical system. We're not controlling the CPU and memory. How do we know that our software is doing its task to control that system when we don't have that system? The easiest way, is to simulate it. We simulate the system by writing equations. We hope the equations are correct or good enough. And then we extract the sensor values from those equations, simulate the sensors, and we connect that to our control software and connect back the output from our control software back to the simulation. This creates a kind of closed loop. That's where the loop comes from, where our control software on our PC is connected to a simulation on the PC, which we can use to determine if the software runs correctly. What does correct mean in this case? Requirements. Do you like requirements? Raise your hand who likes writing requirements. Great, thank you. You're doing a great job for the world. Please continue. Okay, from the requirement, very important, we derive the test scenarios to see if it really does the job or doesn't. In best case, it does. Okay, previously we had purely software on the PC. Now we're getting to the, not the real problem, not the actual system, but a step closer to the system where we're using the actual embedded software on the embedded controller. And you see there, we still have the simulation. But why aren't we connecting it to the real car yet? Because we can really destroy that. And now we actually only want to test a part of the hardware. The part of the hardware we want to test, we actually connect it. We power it up. And we use the part which we don't have, which is expensive, in the simulation we had on the SIL case. And this is called a hill. It's a black box. It's a real big box. It looks like a set of drawers. Who of you works with server racks or has experience with server racks? No one. Ah, you have a few people. Thank you. It looks like the server rack. You have a lot of sliding boxes which you can exchange, and it draws a lot of power, more than a server rack, but still. And you interconnect the ECU and the existing components like sensors and actuator, and to a PC that's running in real time to the simulation. So you have a lot of electrical components interconnected. So this is a more expensive step, but yeah, it tests a lot more. Next step is car, but I'm not covering that here. A little bit about test automation and we're done. Okay, we have requirement. A part of them are implemented. We write some tests, run the tests on hill and sill, get the test result. First iteration done, green, next. We implement more requirements. We create more test cases. We rerun the previous test cases, compile the test results. These are legally binding. If somebody dies, somebody asks us for the test result. Yeah, not fun. Yeah, and that's the end of the story. When you have all the requirements implemented, when you have them all tested, when you have the test results safely stored for a lot of years, then you can safely release the vehicle, people can drive it, and everybody is happy, and you're making a lot of money, and you don't have to work ever again. No. Okay, some references. You can browse them if you like, and we're done. Thank you. Any questions?
Why we don't see hydrogen cars on the road yet?
They're expensive, and we're not living in Japan. Yeah, so for normal consumer, not trucks, it's like, I think the most cheapest one is 60,000 euros. You don't have where to refill them in Romania, for example. In Germany, you only have some stations. And yeah, we're not building stations to refuel because people don't have cars. People are not getting cars because we don't have any stations, and they're still expensive. For trucks, it will look better because, for example, the EU is pushing regulations for for pollution, and you can't make trucks with batteries, not really big ones, and that's why we have trucks very soon, but personal cars not yet. Yes.
Is the security of the containers of the hydrogen really secure? Because I know that was an issue in the past. I mean, because they are highly flammable.
Yes, the tanks are strongly enforced, and we have a lot of emergency shutdown systems. If we detect the smallest leak anywhere, everything is shutting down. So, yeah.
Yeah, but in case of accidents?
It's like with the airbags. You try to detect the accident when it's happening, right when it's happening, and shut everything down as soon as possible. And there are some solutions to get rid of the hydrogen as fast as possible out of the the danger zone where it could become flammable. Yes.
And you are not burning it.
That was a proposition to burn it or in the direction that's safe.
Okay. And do you have here in Cluj any car like this or something?
No.
Okay. But you
not yet.
Okay, yeah.
Maybe, who knows?
Mm-hmm. Nice. Oh.
Yeah.
You spoke about a lot of positive things at the beginning.
Yep.
What's the downside of using hydrogen? Of course, not related to costs and things like this, because we already know about these things. Materials.
You need platinum for the stacks and recycling, and actually the main substance for the stack is a polymer like Teflon. It's very similar to Teflon. It's carbon fluorides. If you know about the environmental and health dangers, then yeah, that's also downside. And expensive metals, of course. Yeah, same as for batteries. Exactly. Yeah, good point.
Okay, good. Okay, thank you, Teofil.
Thank you.